All right, so we're continuing with solving exponential equations. And so again, in order to solve the exponential equations, we need to get the variable out of the exponent. Okay, so to do this, we can find some way to make the bases the same. That's what we had just done with the base exponent property. Or we can rewrite the exponential as a logarithm if the equation has only one exponential. But that's only really going to work easily if the equation has only one exponential. We can make each side of the equation the argument of a log. This is called the logarithmic equality property. Or we can use substitution. And we're going to show you each one of those. We've already talked about the base exponent property. So, solve by rewriting as a log equation. So this was the 15 to the x equals 30 that we couldn't solve before. So we were going to say, hey, I could rewrite this as a log base 15 of 30 equals x, right? Because the question, that is 15 to what power equals the argument. All right. So, and then, of course, log base 15 of 30, we can go and put into GeoGebra. Or you can do a change of base formula and put it in on your calculator. So log base 15 of 30. So we have that's a roughly 1.256. So roughly 1.256. Of course, on the tests, I'm going to generally want an exact answer, and so that's going to mean tell me log base 15 of 30. To the x equals 32. So we can solve that one via the equal base property, but we could also rewrite it, right? Log base 2 of 32 equals x. And this one we can solve exactly with a calculator or whatever that it's 5. E to the negative t equals 0.04. So we could say, so this one will be natural log, right, because that's base e. ln of 0.04 equals negative t. And then we would say, hey, t is negative ln 0.04. And what is that in, what is that? Natural log of 0.04. So that's about negative 3.2. We have the negative on that, so 3.2189. Oops. 3. So it's roughly 3.2189. But again, I'm going to want, generally speaking, the exact answer, right? So the mental trick for this one, y'all, which you've probably used in the past, and it's going to be the same thing for the next strategy, is to take the log of both sides. Take log of both sides. What we're really doing is rewriting as a log. But if we take the log of both sides, in this case, since it's e, we're going to do ln. So it would be ln of e to the negative t equals ln 0.04. And then we know ln of e to the negative t, you can think of that either as, hey, I'm going to have the power rule, so I'm going to pull that negative t out front, and I know ln of e is 1. Or we can say straight up, I know ln of e to the t, ln of e to the negative t is negative t. So this would say negative t is equal to ln 0.04 t negative ln 0.04. But what we're really doing is rewriting as a log. Okay, now this one we do have a first step to do first, right? Because we need to get the log by itself. So we need to divide by 1,000. So this one we're going to have e to the 0.09t is equal to 5,000 over 1,000, which is just 5. And then we're going to rewrite that as a log, right? Log base e of 5 equals our exponent, 0.09t. And then we're going to solve this thing for t. So t is ln 5 over 0.09. And that's it. That is our exact answer. I am not generally interested in decimal approximation, so you won't get full credit for decimal approximation. Please give me the exact, unless it specifically says to round to the nearest whatever decimal place. All right, so we're at 5. That's not a bad place to stop because, I know it's hard to fit in this stuff in between everything else y'all got going on. So we'll try to keep them short.